Hello, this is Lab 5. So for the piano, we have a module piano for the design source. We have the input, which is the clock that comes from the breadboard. Then we have the hush. So hush is when it's 0, then the board makes noise. And then we have 1, so when the button is pressed down, then it mutes the noise. And then we have 4 bits wire in order to select the note. And then we have the output to the speaker. So we have the 17-bit tone, and we use this tone variable to divide the 100 megahertz clock. And then we have another register, which is a 17-bit counter. So then this is the counter that we use to divide the clock. So then we have an always loop with the case. So then this is the mux. So then based on the note, then it selects the tone variable, and then we use the tone variable to divide the 100 megahertz clock. So we can see that when we go up to higher frequency, the tone variable gets smaller because a smaller dividing variable means that the output frequency tone will be higher. And then this part is the clock divider. So at every pause edge of the clock, then it adds to the counter. And if the counter is higher than the tone, then it'll basically reset the counter and then toggle the speaker. So this essentially just divides the clock into the frequency that we want, since each toggle cycle from high to low is 1 hertz. So it's basically 1 square wave is 1 hertz. And then, for example, like for 400 hertz, then we divide the frequency by this number, and then it toggles it 400 times in 1 second to make that 400 hertz sound. Here's a test bench we just copied from the lab manual.
Is the constraint we also copy from the manual. So basically we have the external clock period, and we have the M14. We have M14 for the hush, and we have the pin G18 for the speaker. And here's our simulation. So here is represent 17-bit from 0 to F. So from here I'm starting at 0. So the note is 0 0 0 0, and let's move on to clock 1. So right now we have 0 0 0 1. You can see right here is note 1 and clock 1, and keep move on. Right here is clock 0, and we are at note 2, so it's 0 0 1 0. And here's note 3, we have clock go 1 again, and we have 0 0 1 1. And note 4, we have 0 1 0 0, and so forth. We continue to 17-bit. And here's our schematic.
Here's schematic. So basically, this part is the counter. So the counter is triggered at every pause edge of the clock, and then the counter also goes to the speaker. So, I mean, not the counter. The clock also goes to the speaker. So then once the counter adds up and it's equal to the tone, then it basically goes here and then toggles the speaker sound from high to low or low to high. And then the hush here is connected to the speaker mux, so that if hush is toggled, then it doesn't toggle the speaker if hush is pressed down. So here, next up is our we generate the bit stream and then we implement onto the device. This is lab 5.
Hello everyone. So right now we put in the blackboard, and here's our speaker. So right now I put the info into the speaker. So right now you guys hear a sound, and here's our hush is M14. When I click it, it's silent. So when I not click it, it make noise. So right now we at 0 0 0. You can hear the sound very like right now I click 0 0 1, 0 1 0, 0 1 1, and 1 0 0, 1 0 1, 1 1 0, and 1 1. And right now we have 1 0 0 0, 1 0 0 1, 1 0 1 0, 1 0 1 1, and 1 1 0 1, and 1 1 1 0, and finally 1 1 1 0. Okay, thank you.